Hi everyone, welcome to a new video. This week I'll be covering something a bit different, that is actually damn vulnerable DeFi applications. You all know smart contracts and crypto are very big these days. It's been big for a long period of time. So this video we are actually going to cover a damn vulnerable application that is actually based on decentralized finance or DeFi. So here, this is the project that I am actually working with here. So in Damn Vulnerable DeFi, we are actually trying out the first challenge, that is unstoppable. So let's get right into it. The challenge is actually about a vault which has almost a million DVT tokens deposited. So think of these as normal tokens, and it's offering flash loans for free for a grace period. And the aim here is to actually stop the world from giving out flash loans. So that's a challenge. Let's see how that can be done. So I have already cloned the repo. So I have already cloned the repo and have all the source here, or the challenge source here. I'll need to explain you a few things if you're really new to DeFi. There are some concepts that are new here. Um, we are using a programming language called Solidity, which is unique to Ethereum. Ethereum frameworks, they build most of their application using Solidity. Before getting into the challenge, we need to understand few of the things. That is, one is ERC20, and the next one is ERC4626. ERC4626 is mainly describing about how a vault needs to be created. Think of a vault where you are having a lot of shares or tokens present. Mostly it will be tokens here in ERC4626 because it's a vault. And then ERC20 is your token. And you are doing a lot of imports which are pretty different here. You're using something called safe transfer lib. So basically what it means is that you can use your ERC tokens and you can use functions from the vault using the safe transfer library that is present. So you will be using that to send and receive tokens from the vault, uh, send and receive tokens from the vault. Now, another pretty interesting thing is that everything in the vault is in terms of shares and tokens. So you will have a lot of tokens which will actually be translated into number of shares. Think of it like basic shares. So you have 100 token, where one token is equal to one share, then you will have 100 share. So everything is calculated in that manner. So if uh, in this challenge there's around 100 million tokens, or how much did the challenge say? How many? A million DVD tokens are present, and million DVD tokens are converted into their corresponding shares as well. So these are some of the basic things that we need to know. Now let's actually look at how it's implemented. So you have an unstoppable vault. This is a flash lending. So now that's another question. What is actually flash loans or flash lending? Um, Flash lending is actually used for arbitrage. So arbitrage basically means you will get tokens from one place and or multiple places, and you will sell it at a different place. Uh, So you are actually trying to not exploit. You are actually trying to get that change in price values in milliseconds or in that second. So that if you're actually handling a lot of tokens, that change in the value can benefit you. So that is basically where flash loans are used a lot. You can check out what is arbitrage There are a lot of documents explaining it way better than this. Um, then it's also used for actually getting a better loan. So you say your payment is higher in one loan, so you can use the flash loan to pay it off and get a new loan at a lower rate. So that's kind of one area that is used as well. Then you have a reentrancy guard. So reentrancy is an attack on um, blockchain, basically where you are calling one function over and over again before it completely finishes executing. So that was an attack that is there. So this one makes sure that if you're taking a very small example, like the function executes, and only then are you allowed to, run it again. So basically preventing you from reentrancy. Some of the basic things here, they again the vault is being used here. Um, okay, so they have a fee factor that is paying 5% either and grace period of 30 days. Grace period is not actually for the loan, it is actually for how much time the loan is applicable and stuff. You have a timestamp plus grace period for the extent which the loan is active for, or no, the flash loan is active for. These are all basic checks, callback failing, if there is invalid balance, invalid amount, things like that. This is a constructor that is creating an object here for the token owner and fee recipient. They are creating a vault uh, with TDVT, so that is actually the token here, and DVT will be the shares. Okay. Okay, so max flash loan is also here. That is how much loan that can be given um, in a single go. It's also using reentrancy check. It's checking the asset as well, returning the total assets. Then flash fee. Um, how much fee are you deducting for while you're doing it? But there is a check here if they're giving an actual epoch time here, and if the epoch time is less than the actual one that they are giving, and if the amount is also less than the maximum that they want to give out, there won't be any fee levied. Otherwise, they are actually using a fee factor and they are multiplying it with the amount. So some basic stuff. The assets are being collected here. Again, a function to do the flash loan. The actual flash loan here, if amount zero, invalid amount, you're actually taking the assets, tokens. Safe transfer is a method from the safe transfer library. So we are already taking it. Um, and going further, flash free amount. You are checking for a callback failed. Okay, perfect. So I think we covered some of. So there is a before withdraw function as well, and execute the actual changes and pausing or unpausing the contract. Then there's an unstoppable monitoring file as well. So it checks what happens during the flash loan and checking the flash loan and details. Now, okay, there is a lot of things here. So what exactly is the vulnerability? The vulnerability is arising because the vault always checks the number of shares that it has, and it is checking that with the total balance. So it knows how much each share is worth. So it always checks how much shares are there in circulation. It computes that, and it understands that the total shares is the value of the vault, or the amount that the vault is actually containing. But what if you send random tokens to the vault without depositing anything? If you deposit something, you're supposed to get a share. But if you're not depositing anything, you're just sending tokens, and uh, you're not actually using the deposit method in the vault, and you're just sending tokens using transfer, what happens is that the vault's actual token balance will be higher than the actual number of shares that is being distributed. So due to that, here in the flash loan method, checking if the amount is zero, and if it is nothing, then it is giving invalid amount. And if checking the assets that are there in the vault, and if that is the same as the token that we are using, then it is okay. Otherwise, it's unsupported currency. But now you here, so balance before is equal to total assets. So total assets is actually the total number of shares. Now they are using that to check the balance before. So they are actually converting that to convert to shares total supply. So that's what exactly what I was talking about. So you're converting all the total number of shares in supply, you're computing the value of that, and then you're checking the balance before. And if both are different, it will actually fail. It is actually correct, but they didn't think of the case where uh, you are actually sending in tokens just to the bank, just to the vault without actually getting any shares. So if there is 1 million there and there is 1 million and one token, then this check would actually fail. So that is a bug here. If that is done, then the vault will stop giving out loans, basically becoming unstoppable. That's the pun. Now let's see Unstoppable's test solution test file. So this is the file that you have to modify. They are actually giving in 1 million tokens. You can see e raised to 18, that is uh, e raised to minus 18 is the e raised to 18 is the number of tokens that can actually create one. So you just can add one, or uh, in human readable format, 1 million token is equal to 1 million into e raised to 18. So that is what it means. So 10 token is 10 into e raised to 18. So these are basic checks that they are actually doing here. And this is actually the function that is the test unstoppable function. Okay, it's already giving me some random things based on stuff. But what do I really need to do now? I just should do require. Why are you doing require? Requiring is making sure that your condition anyways succeeds, and we do token dot transfer. So we need to transfer. We need to do transfer from, right? Okay. Okay, there is a lot of things. I don't think we need all of these things. We need an address. Okay, this is confusing me. We need address of the vault, right? So we need address of vault plus how much are we actually trying to send the vault. Okay, we are right here. Okay, am I outside the function or what? We don't need this, right? What am I doing? We need address of vault and 1 e raised to 18. That should be enough for this thing. All right. Oh, I didn't close that. So require token transfer from address, transfer from, hmm, or is it transfer to? Transfer from address from to address to and amount. Transfer to, this should be right. Or should I even need that? Token dot. Okay, I'm doing a require token transfer. Okay, this should be enough. Console. I want to check what happens here. Console dot log vault balance is total assets. That should actually print out the vault balance. But I also want to see what would be the balance before if I send it. Console.log. I don't want the player address. I want vault balance. Just use the same thing that I wrote here. Copy that. Paste it right here. Alright, that's perfect. Now I saved it. I'll go back here. These are some of the old test cases that I was trying to do. So how we are trying this out is using something called Forge or Foundry. You're using Foundry to set everything up, and we are trying that to test it out. In order for you to test anything here, you need to actually have ls minus a. You need to actually set up an environment variable with your mainnet URL. Your mainnet URL will be the URL that you get from a Web3 development platform like Infura. You can log in and create your own API to connect to the mainnet. So you need to add it there. I am not exposing my API endpoint, that's why I'm not showing you that. Anyways, let's try this thing out. We are gonna do, this is the testing. I'm actually testing the um, unstoppable one, and I want it to be verbose. Perfect. So it passed, and you can see there is one right here, and there is this huge number of zeros, and there is 1,000,001 right. Okay, perfect. If you are still not clear what's happening here, I will make it way better by actually doing something. Yeah, this is what I want. This is now making into human readable. Now if I run the test right, perfect. So that is the actual number of tokens there, and I have added one more token to it, which basically solve the challenge. I could also would have done something way easier by just adding just a one, which would have been enough to increase, but in order for you to understand it way better, I just did this. Because if I just do one now, it doesn't understand that. Perfect. So now we have actually solved the challenge. So this is basically unstoppable. I hope you liked it. I'll be going through more of these challenges in the coming weeks. Thank you so much for watching. Take care.